Today we're going to learn how to work with Sig Figs. Sig Figs are going to be something that's going to follow you through the entire class here, as well as through any college laboratory science you take. They're very, very important. Basically what a significant figure does is tells you how precise your measurements are. Now your measurements can only be as precise as the instruments that you use to gain your data. So it says a digit that must be estimated is called uncertain. We know that when you're taking a measurement, you always include one estimated value. So for example, if you're measuring with the graduated cylinder, you're always going to estimate if it's between two lines on there. You always want one uncertain value. So it says a measurement always has some degree of uncertainty. So remember, when you see the digital balance, sometimes that last number is going to be fluctuating up and down. That's because the last digit is always uncertain. We can't see exactly how large something is, or we can't see exactly how much something weighs because we just don't have a tool that can go out to infinity. Okay, so why is there uncertainty? Again, that's because the tools that we have today, and will ever have, only have so many values. So this digital balance can give you precision of one place past a decimal, whereas this one, which is probably thousands of dollars more, if you look, the decimal's way over here. So it has 1, 2, 3, 4, it has 5 values that it can give you. So this one is going to give you much more precise data. But it's still uncertain because the measurement stops here. We don't get numbers out forever. So while this one is much more precise than this one, there is still uncertainty in the measurements that these give you. The last value is always uncertain. Okay, so the first thing we're going to learn is how to count Sig Figs. So say you already have data and you need to know how many significant figures it has. This is going to come up a lot in this class, especially with your calculations. So the first rule, non-zero integers always count as significant figures. So that's easy. These are all non-zero. So this value has 1, 2, 3, 4. It's going to have 4 significant figures just because they're all non-zero, so I counted all of them. Next rule, leading zeros do not count as significant figures. So leading means it comes at the beginning. So this is at the beginning, so I'm going to skip it. This is at the beginning, so I'm going to skip it. 1, 2, 3. So this measurement has 3 Sig Figs. Still pretty easy. Okay, sandwiched zeros. Sandwiched zeros always count as significant. So if you're counting the values in this one, 1, 2, this 0, because it's sandwiched in, is counted. So 3, 4. This measurement would have 4 significant figures. It doesn't matter how many are sandwiched either. This value could have been 16007. Then it would be 5 Sig Figs instead of 4. Okay? So no matter how many are in there, as long as you have non-zero digits on either side, then they are significant. Okay, trailing zeros, or zeros at the end. Trailing zeros are significant only if the number contains a decimal point. So because this value has a decimal point, we're going to count these zeros. This is going to be 1, 2, 3, 4. So this is going to be 4 significant figures. On the other hand, if this value had been 9300 with no decimal point, then we would ignore these. We just do 1, 2 Sig Figs. Okay, so this one is a kicker that throws people off. Just remember that when you have a decimal, it makes everything significant. Okay, so let's practice with those new rules. You should have these in your notes if you need to fill them in as we go. So, because there's a decimal in this one, all of the zeros afterwards or at the end are included. So this is going to be 1, 2, 3, 4, 5. This value has 5 Sig Figs. Because there's a decimal in here, this 0 at the end is significant. 1, 2, 3, 4. Okay, these two are sandwiched in, meaning they're going to be significant. This value has no decimal place. That means a 0 at the end is going to get ignored. So this one's going to be 1, 2, 3, 4, 5 Sig Figs. Okay, Scientific notation, you don't need to worry about the times 10 over here. It's not included in the significant figures part of it. So we're just going to count our non-zero digits. 1, 2, 3. Okay, this one. You always skip the leading zeros, the zeros at the beginning. So we're going to skip, skip, skip 1, 2 sig figs. Okay, this measurement does not have a decimal. That means my trailing zeros are all going to get ignored for 2 sig figs. Okay, so now we're going to look at how you're going to work with basically your calculations in the lab. So your rule for multiplication and division, sig figs in the result equals the number in the least precise measurement used in the calculation. So what that means is it's going to have the same number of sig figs as the least amount in your problem. So if this one has 3 sig figs and this measurement has 2 sig figs, your answer is going to have 2 because that is the least number of sig figs in the problem. So if the calculator gives us this value, we would need to round so that this has 2 sig figs. That brings our answer to 13. Okay, so that's what you would need to put, for example, in your calculations table in a lab report. You're always going to want it to be the answers that you turn in are already rounded to the correct number of sig figs. Okay, so let's look at a couple of these here. So if we're multiplying these two numbers, this one has 3 sig figs, this one has 2, because of the decimal it has 2. So I'm going to round to 2 sig figs. So this value, rounded to 2 sig figs, is going to be 23 meters squared, right? That's 1, 2 sig figs. This value, because there's a decimal, we count all these. 1, 2, 3, that's 4 sig figs in this one. 3 sig figs here. 3 sig figs is the smaller number, so I need to round to 3 sig figs. 4.219. Okay, since the number after the 1 is a 9, it means we're going to want to round up. 4.22 grams centimeter cubed. Cool. Next one. Beginning zeros, leading zeros are ignored. That means I have only 1 sig fig here. So my answer is going to have to only be 1 sig fig. So remember, leading zeros are skipped. So skip, skip, and then I need 1 sig fig. 5. Okay? So that only has 1 sig fig. This value has 2 sig figs. This value also has 2 because the decimal makes this 0 significant. So my answer needs 2 significant figures. That's going to be 240 meters per second. Okay? This trailing 0 is insignificant because there's no decimal. So this meets the this meets the requirements. It has 2 sig figs in your answer. Okay, this one. 1, 2, 3, 4, 5 sig figs, whole bunch in that one. 1, 2, 3 sig figs. So I need to round this so that it has 3 significant figures. So 5, 8, 7, let's see. 2 is a really small number, so I'm not going to round up on this one. I'm going to do 5,870. Okay, and that answer has pounds per feet. That answer has 3 significant figures. Okay, this one, 1, 2, 3, this has 4 sig figs. That ending 0 is significant because of this decimal. This one has 3 sig figs, so let's round to 3 sig figs. That's 1 sig fig, 2 sig figs, and 3 sig figs. Because there's a number 5 or greater after the last one, I round it up. Grams per milliliter. Okay? Okay, one more rule for sig figs. When you're doing addition and subtraction, the number of decimal places in the result equals the number of decimal places in the least precise measurement. So this one's just a little bit different. You want to do the least number of decimal places in the problem. So this value goes one past the decimal place. This one goes 3 past. So we're going to be rounding to one decimal place. So our answer is going to be 18.7. We leave it at 7 because the 3 is such a small number. So that's going to be 1 place past the decimal. It's not necessarily 2 sig figs. you have to round to the same number of places past the decimal. So let's do a few of those. In this one, our least amount of decimal places is 1 place past the decimal. So this is going to be 10.2. That's 1 place past the decimal. This one also, the least amount of decimal places is 1 place. So 76 point, I'm going to round that up to 3 because there's a 7 after it. 2 places past the decimal and 3 places past the decimal. So I'm going to round to 2 places past the decimal. 2.39. Okay, that brings us to 2 places past the decimal. This one, 1 place. Yeah, so I'm going to round to 1 place past. 709.2 liters. This one, 1 place past the decimal, and okay, so I'm going to round to 1 place. 18.21 and 1 place, 6 pounds. Let's see, 3 places and 3 places. Well, that makes it easy. Since these are both 3 places, we need another value. Okay, so the calculator gives us this exact number, but if you just write this down, you don't have enough significant figures. So what you need to do is add a 0 to make your answer have the correct number of digits. Okay? So these are about all the kind of problems you can come across. We will do some more in class. I will see you then.